Most AIs are great at playing chess, generating art, or even mimicking human voices. But when it comes to real-life decision-making, the kind that actually keeps the world running, they fail miserably. And we're not talking about sci-fi level philosophy or moral judgment. We're talking about something as essential and down-to-earth as planning delivery routes, scheduling surgeries, or making sure a grocery truck doesn't waste fuel zigzagging across a city. Until now. Because DeepMind, yes, the same AI powerhouse that beat world champions at Go, just pulled off something that could fix one of artificial intelligence's biggest blind spots. And if this tech works at scale, it could change how your online orders get delivered, how your doctor books an OR, or how your city clears up traffic congestion. Think of it as giving AI actual street smarts, a blend of speed, intuition, and decision-making under pressure. Let's break it down. Real-world logistical planning is ridiculously complex. It's what computer scientists call a combinatorial problem. There are just too many possible combinations to consider, and the rules are tight. A delivery truck can only carry so much. Each delivery might have a time window, and the traffic completely unpredictable. Now imagine you're managing 50 drivers across a city, each needing to visit specific locations within certain hours with limits on how much cargo they can carry. You can't just wing it. Every decision matters. Every minute wasted or wrong turn taken adds cost. In tech speak, these are NP hard problems, the kind that even supercomputers struggle with. Finding the absolute best answer, you'd be waiting a very long time, even with today's fastest chips. So, naturally, the idea was, let's use AI. But here's the catch. Most AIs suck at this. Neural networks, those brilliant pattern recognizers behind deepfakes, voice assistants, and smart recommendations, are not built for hard rules. They thrive on patterns and probabilities. Feed them images, and they'll tell you what's in them. Give them music, and they'll generate more of it. But ask them to plan a logistics run with rigid constraints, they're like a deer in headlights. Because these problems aren't about fuzzy predictions, they're about clear, discrete yes or no decisions. Like, can this truck carry that much? Or can it arrive between 9 and 9:30 a.m.? Traditional mathematical solvers do better here. They use brute force logic, but they're painfully slow, and they assume you have all the information up front. In real life, that's rarely the case. So, what's the solution? Enter DeepMind with an elegant idea. Combine the intuition of neural networks with the logic of traditional solvers. The innovation? Something called MCMC layers, short for Markov chain Monte Carlo layers. Sounds complicated, but here's the simple version. Imagine planning a delivery route. You've got an okay plan, but you want to make it better. So you tweak it. Maybe swap 2 stops or move 1 delivery earlier. You check if the change helps. If it does, you keep it. If not, you try something else. That's basically what MCMC layers do. They turn AI into a smart explorer, constantly trying new combinations, checking if they're better, and learning from every attempt. And the secret sauce? Simulated annealing. Yes, like the metalwork process, you heat metal, then slowly cool it to remove defects and make it stronger. DeepMind uses that same idea. Start with wild guesses, then gradually narrow down to better and better plans. All of this happens within the AI itself, inside the neural network. It's like grafting a decision maker onto a pattern recognizer. Here's why this matters. Most planning systems look for perfect solutions, which takes forever. DeepMind's method focuses on quick, smart guesses, called local search heuristics. These aren't exact, but they're fast and effective. And the best part? The AI can learn from them, because these heuristics are differentiable. A fancy way of saying the AI knows how to adjust its guesses based on how well it did. They also introduced something called Fenchel-Young losses, basically a scorecard.
So we've always been interested in building general AI, or AGI, from the beginning of DeepMind. That was always the aim. In fact, that was the original aim of AI as a field back in the 1950s. So in some senses, we're kind of realizing that grand dream. On the way, you can use those general techniques for specialized solutions to problems. So AlphaFold is a good example of that, where the problem's well specified, it's enormous value to society, and in this case, biology and medical research in its own right for what it can do. So it doesn't really matter what methods you use, but you start with the general methods and then you add some specializations on top.
Even if the AI makes just one small guess, close it got to the best possible answer. That keeps the learning on track and cuts down training time. They even experimented with how to kickstart the AI. Starting from scratch is hard, but give it a pretty good plan as a draft, that helps a lot, like giving a student a study guide before a test. The team tested this on a brutal challenge, the dynamic vehicle routing problem with time windows, DVR-PTW, a real-time planning nightmare used in a major AI competition. Euro meets NeuroPS 2022. Here's the setup. Delivery requests keep popping up all day. You have seconds to plan routes for trucks while respecting delivery times and truck capacities. It's basically a real-time strategy game with packages instead of soldiers. DeepMind's AI, with its smart MCMC layers, was put to the test. It had just 1 millisecond to make a decision. That's faster than a blink. And yet, it came up with routes that were only 7.8% worse than the perfect plan that knew the future, called the anticipative baseline. In comparison, the old school method, which just jiggled things around randomly, called perturbation, was 65.2% worse. That's the difference between your package arriving tonight or next Thursday.
AI is going to be this fantastic technology if used in the right way, but it's a dual purpose technology and it's unbelievably powerful. It's going to be unbelievably powerful. So what that means though is that bad actors or would-be bad actors can repurpose that technology for potentially harmful ends. So one big challenge we have as a field and a society is how do we enable access to these technologies to the good actors to do amazing things like cure terrible diseases at the same time as restricting access to those same technologies to would-be bad actors.
Even with more time, like 1000 milliseconds, the DeepMind model stayed competitive, 5.9% cost versus the baseline's 5.5%. Not only that, they found ways to improve even more by starting with good guesses, adjusting the AI's temperature, its willingness to explore versus settle, and running multiple explorers in parallel like a team of digital strategists. And yes, they backed all this up with rigorous math, showing the system converges or gets closer to the best answer over time. No flukes here. Why this matters for you. This isn't just about trucks. Think about the ripple effects. If AI can get smart at real-world planning, it could transform industries. Retail. Your groceries arrive fresh and on time even during rush hour. Healthcare. Hospitals can schedule surgeries more efficiently and reduce wait times. Public transport. Buses and trains adapt in real time to traffic and rider demand. Event planning. Festivals, concerts, and major events get smoother logistics. City planning. Smarter routing reduces fuel use and cuts emissions. It's like taking the chaos of the real world and giving it an intelligent manager that never sleeps. And the best part? The whole system runs on just a single CPU. No crazy hardware, just smart design. Of course, nothing's perfect. DeepMind's method required fine-tuning, adjusting how the AI explored different solutions, optimizing the loss functions, and managing the temperature setting. It's not yet plug and play, but the progress is undeniable. The researchers are already looking into better heuristics and more efficient ways to explore the search space. The next generation of this AI could be even faster, smarter, and easier to use out of the box. This could be the missing link in real-world AI. Systems that don't just recognize patterns but make decisions, adapt, and act in complex environments with limited time and imperfect data. It's a shift from static intelligence to dynamic intelligence, a brain that can react to what's happening now, not just what it's been trained on. It's also a big leap toward more trustworthy automation. Because when AI can handle the gritty, messy logistics of life without breaking the rules or wasting resources, it becomes something more than a fancy algorithm. It becomes useful. So what starts with planning a grocery delivery might end with AI optimizing how cities flow, how people get healthcare, and how we manage the incredible complexity of modern life. Is this a new chapter in practical AI? Are we finally moving beyond flashy demos and into tools that actually make life better? What do you think? Will AI become the world's best planner? Or should we still be worried about who holds the keys? Let us know in the comments. And if you found this deep dive fascinating, make sure to hit that like button, subscribe to WebSpark for more cutting-edge tech stories, and don't forget to check out Judy F Marketing for smart marketing insights powered by tech. Thanks for watching, and see you in the next one.